So we're just going over the homework on page 27. We already did the top section. We're here at B now. So with B, again, straight off your reference table, rock salt made out of halite, it's crystalline, and it has fine to coarse grain. Rock gypsum's made out of gypsum, it's also crystalline and fine to coarse. Dolastone's made out of dolomite, crystalline, and it's fine to coarse. Limestone is calcite, which is crystalline or bioclastic, and it's microscopic to very coarse. Coal is made out of carbon, it's bioclastic, and it's very coarse. Yes. Yep. So we're down here. How are crystalline and bioplastics classified? By their composition. What process do crystalline rocks form? This happens when crystals get compacted together. Coal, where does coal come from? It's plant remains. And what is limestone sometimes made out of? Shell fragments. I do want to help a little bit because I have had people stop and ask me about this one quite a bit. So I know we did sand and sandstone for the first one. Now I know this reference table is kind of tricky, but it's just decimals. And I know the lines are spaced weird apart, but for example, if we have 1, what's the next line? No, for reals. If I have 1, what do you think the next line is? 2, 3, 4, 5, 6, 7, 8, 9, 10. It works the same down here. Here's 0.1. What's the next number? 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then up to 1 again. Same here, 0.001, the next line is 0.2, and I think that was the next question, 0.002. So here's 0.001, so the very next line is 0.002, which puts you in between the 2 dotted lines for silt. So that's how this one is silt. And then when you flip it over, silt makes siltstone. And the next one was 0.007. You could have done this, wait, was it 0.020? So that's down here, here's 0.001, so 0.002, 0.003, or you can see that 0.006 is the dotted line. So 0.007 is right above that dotted line, and that makes it sand. So again, sand, which makes sandstone. So you do that for the rest of them, and then the next one, the 0.9 should be pebbles, and because it said it was round, you get conglomerate. 0.5 is a pebble again, but because it said it was angular, that's breccia. This one, 0.00004. That's not even on the reference table. That is smaller than this number, 0.0004. So it's even smaller than this. So that's in the clay section, which is shale. And the last one is silt, which makes siltstone. Anybody want me to go over any of those? No. Anybody? No, I've gotten 2 no's, no yeses. All right. So there is more to practice with the sedimentary rocks. You'll see the next few pages are more questions. We're going to come back to reviewing that. I want to get you started to make sure you're introduced to the metamorphic rock chart on page 32. So just like we've been doing, head on over to the notes section about metamorphic rocks on page 32. And I'm not sure. This one's going to be kind of hard to see. And if you have trouble seeing, call me over because I can show you my copy of it then. I do realize I made this one kind of small and I can't enlarge it now. So let me know if you can't see. So the metamorphic rock chart, same idea as the igneous rock chart, same idea as the, so what did I say? I meant to say same as the metamorphic rock chart. Oh my gosh. Hang on, I gotta take a minute to. Oh, you broke it, nice job. All right, I'm gonna start over just because I just said 10 things wrong. So here's the metamorphic rock chart. It works the same way as the igneous rock chart, the same way as the sedimentary rock chart, and very similar to the mineral rock chart. It's the same idea. We've just got words on here that, again, you don't know yet. So take a look at this chart, guys. Everybody look at the chart either on your notes on page 32, or if you can't see it because yours printed blurry, I know mine did. It's on page 7 of your reference table. It's the bottom half. So take a look at this chart, just like we've been doing for all the other rock charts. If I handed you a pile of metamorphic rocks and told you to make 2 piles, what would you be separating them based on according to the reference table? No, go ahead.
Foliated, or whatever it's called.
Okay, wait, hang on. What did you say, Riley? Formation? Yeah, in this case, it's not how they formed, no.
Foliated.
Yeah, their texture. So the first group, which is like you were saying, whether they're foliated or non-foliated. Now, first of all, does anybody have any idea what the word foliated means?
I've heard exfoliated.
Okay, exfoliated sounds similar. What do you do when you exfoliate? Huh? No.
Clean your face.
You clean your face. If you exfoliate your face, or if you get a pedicure, they'll exfoliate your feet. But what exactly are they doing when you do that?
Cleaning your pores.
Yeah, kind of, but I mean, yes, in the long run you are. If you exfoliate your feet during a pedicure, come on, somebody's had to have this done. Wow, what do they take off? What'd you say, Patty? Dead skin. They take off the layers of dead skin. Exfoliation means to remove layers of dead skin. So foliated, what do you think that has to do with it? Well, it's not necessarily adding, but layers. Another way I think about it is if you take a piece of paper and you fold it. What did I just create? A bunch of what? Well, okay, that too. Layers. So I just created a bunch of layers. I took one sheet and made it into layers. So foliated means the rocks have layers. So texture, there's 3 types. I'm gonna put them all up first, and then I'm gonna let you copy them. I'm gonna turn off the lights in case that helps you see better.
Thank you.
You're welcome. I know they're small, so if anybody needs me to come over or read something, let me know. So I'll let you write them, and then we'll go through again what they need.
The second banding.
Yes, the second one is banding. Where are we? Where? Banding, alternating colors. And I'm going to go through exactly what each one of these mean in a second for you. All right, so I kind of want to show you what these mean. So again, we have the top half of the chart is all foliated. So this whole section, so slate, highlight, schist, and gneiss are all foliated. So in general, that means they have layers. So foliated means layers. All 5 of these will have layers. But as you can see, one of them, so the rock named gneiss, has what's called banding. And banding is when the layers are alternating in color, meaning it goes pink, black, pink, black, pink, black. So basically like zebra stripes. The rest of them, so slate, highlight, schist, they all have just plain old mineral alignment, which just means their minerals are just lined up, but they're all the same color basically. And then finally, the bottom half just means no layers. Let me show you some of these. Hopefully they show up on the screen here. I'll pass them around as well. Which one is this? Oh,
Oh,
that didn't help. Let me see if it helps by putting it on white paper. You can't see it perfectly, but you can get the general idea. Does it have layers? Yes. Is it mineral alignment or banding? You don't see the white layer, then the black layer, and then a white layer, and then a black layer? Okay. So if that's banding, and how do you know that's banding? Oh, that's a better view.
oh, yeah.
That's better. How do you know? Different colors. We've got a white band that goes around, and then a black band. This one, I don't think you're gonna be able to see. Well, what do we got? Layers or no layers?
Layers.
See the different lines in there? Those are layers. So this one is just mineral alignment. Thank you. The minerals are just lined up in this one. Then we've got this guy. No layers. So that's non-foliated. If you get one that has banding, it's your lucky day, because what do you know with the banding ones?
That's only nice.
There's only one that's got banding, and that's the mineral. This is pronounced gneiss. So that's again what the first column means. After we decide if they are separated by foliated or non-foliated, grain size is next, but take a look at grain size. Is grain size super useful this time? No, they're practically all the same. Slate is fine, phyllite and schist can be fine, coal is fine, hornsfeld could be fine, quartzite marble could be fine. So out of the 2, 4, 6, 8, 9 of them, 7 of them can be fine. So texture means not, or grain size means nothing this time. So again, we'll put that up there so you can have the definition, maybe. So grain size is how big the crystals are once again. And if you want exact numbers, you can refer back to your ESRT on the igneous rock chart for what those sizes mean. Now the composition, again, is the kicker. So the composition, the bottom, middle bubble, it's what the rock's made out of. Hopefully by now you know that definition. and they decided to mess with your head again. Because they want to make sure you can read all sorts of goofy charts. That is the goal of the regions for these couple of chapters. Yes, maybe if you learn something about rocks, that's great. But what they're trying to make sure you know how to do by the end of this chapter is know how to use these weird, wacko charts. What I mean is, let's look at the composition. Well, let's take the easy part first. Take a look at the non-foliated. Pretty easy, right? What is anthracite coal made out of? No, anthracite coal, what's it made out of? Carbon. What's quartzite made out of? No, guys, quartz. What it's made out of is the composition. Marbles made out of calcite or dolomite. That's easy, right? What's the heck is this bar graph situation here? What do you think it means? Do they all have it? So let's take a look at slate.
How much they have?
No. Take a look at slate. No, here, wait, let everybody think. Look at slate, guys. What do you think slate is? What's its composition? I said, let everybody think. You gotta stop shouting stuff out right away. Slate. Why does Jake say it's made out of mica? What do you think, Braden? Okay, what's the highest? Mica, okay. What do you mean it's the highest? It's the tallest. All right, that doesn't, I think I know what you mean. No, I actually don't. So guys, how does Jake know that mica? Not because it's the first one. Because it's the, what'd you say, Gabby? The box. It's the only one. So slate, can you not?
Sorry.
Slate, the only one that's in there because it's the tallest. Yes, so I kind of know what you're talking about. Slate, the only box that's in slate is the mica box. Let's go on the same idea. Here's phyllite. What's in phyllite? All of them besides this one. Yeah, Braden. Use this sink over here. Just move the rocks. So phyllite's got all the little boxes except for it doesn't have pyroxene. How about a piece of schist? What does a piece of schist have in it? Everything. See how all the boxes could be in a piece of schist? Now, does a piece of schist always have pyroxene in it? No. Why does a piece of schist not always have pyroxene in it? Right, because that piece of schist, the box doesn't go all the way up. So it means sometimes pieces of schist could have pyroxene in it, but not always. No. Boring group here. Couple people?
Yeah.
Okay. How about nice? What's in nice? Nice. All of them. So nice, unlike schist, doesn't have all of them, or always has all of them. All right, I'll move on. The next column is type of metamorphism. There's two choices there, regional or contact. Regional, like a region, is a large area. So whole region gets heat and pressure. Contact is just when a small group gets touched. Type of metamorphism. So underneath that box, it says type of metamorphism. We're almost done. Sorry, the boxes are so small this time.
I can't read what's behind that. The page.
It says type of metamorphism. So once you're done writing, I'll go ahead and explain these three, or two, I'm sorry. So regional happens, because where do you think, how do we get enough pressure and enough heat on Earth to change rocks? Where do you think that's happening? Inside there. So first of all, it's gonna be really far inside the Earth. But what is pushing? What could possibly be two things that are pushing to make tectonic plates?
If you were to let her finish, like,
We got two plates coming together like this. Right, when two plates come together, what do they make? Guys, anybody, when two plates. Mountains. You guys should at least remember that basics about plate tectonics. Two
And
plates come
valleys.
together, they
Don't do
push
valleys.
together. Imagine how much pressure there is to build a mountain.
I'd say about 60 PSI.
There's a lot.
a little bit more. Like 60.
There's so much pressure that it can make a mountain. There's so much pressure that it's changing all of those mountain rocks because there's so much heat and pressure involved in that. But contact's a little different. So contact, I'm hot lava. And do you mind if I touch your shoulder? I'm hot lava. Jake is a pile of limestone. So Jake is limestone, I'm hot lava. What's happening to Jake's shoulder? It's burning. It's getting, I checked. It's burning. It's getting charred. It's turning colors. It might feel weird. His shoulder has burned and changed. But what's happened to his toes?
What kind of witchcraft are you?
What happened to his toes? Nothing. Like, why did nothing happen to his toes? Because I didn't touch his toes. That's what contact. So that's what I mean by contact. I literally mean touching. So that's when only the area that's getting touched is going to change. So when a volcano is bringing up its hot lava through the earth, and that hot lava is touching the rocks around it, it will burn the rocks around it, just like my hot lava burned his shoulder. But his toes are fine, so it only changes what it touches. Moving on to this bottom bubble here, the comments. Take a second, I want you to read the comments. So everybody right now is reading the comment section. Reading the comments right now. So when we read the comments, what do you see in those comments? Metamorphism, so change. What else does it say though? Metamorphism of limestone. We got one down here that says a metamorphism of limestone. What do you think that means? For marble, it's a metamorphism of limestone. It means it was once limestone. In fact, that's the example I just used for Jake. Okay, Jake was a pile of limestone. I touched his shoulder and I changed it. Remember, metamorphism, like when the butterflies do metamorphism, it just means to change. So that means I changed Jake, who was a pile of limestone. I changed him. Now you know his shoulder's made out of marble. Okay, it says this for some of them, not all of them. Slate, for example, is a metamorphism of shale. So the shale that you guys will skip stones with when you're down by the creek, if you give that a lot of heat and pressure, it will metamorpho, it'll change into slate. Some of them don't tell you what they used to be. So none of these say. But here, Anthracite coal used to be bituminous coal. Quartzite used to be sandstone, marble used to be limestone. So the comments section, it says extra stuff to help you identify the rock, or it tells you what the rock came from, and that's actually the parent rock. So the ones that don't tell you where it came from will actually give you some helpful hints. For example, for that piece of schist, it tells you it's got platy mica crystals visible from the metamorph. Oh, that one actually does tell you. So it's a metamorphism of clay or feldspar. Phyllite, though, tells you it's got shiny microscopic crystals. So that one's going to have little sparkles in it. So it either tells you about it or it tells you where it came from. The last two bubbles are super easy. We got the rock name. And the map symbol, it says on the regents. What does it say? On the regents, they will always use this symbol to identify the rock on the map. Again, just like with the sedimentary, you can ignore this group until a couple months from now. Just remember that map symbol does not show what it looks like.
Isn't it crazy? Sometimes don't you just think about how times there's so many people.
I don't need you interrupting right now.
Oh, gosh.
You're in trouble now.
So right now, you don't know too much about metamorphic rocks. You know the basics. You know what it means to be foliated and non-foliated. You can hopefully use this reference table to answer a few questions. There's a little bit more notes to do when next time we're in class. But for now, I'm going to call it quits. Now, I will not be here tomorrow. You are going to do practice using these charts we've learned the last week. Yes, so it's practice reusing the igneous, sedimentary, and metamorphic charts. You're going to have questions to do in class. If you don't finish them, they'll be homework. Remember, you have no school on Thursday. And I will see you again on Friday. The quarter closes Friday. So make sure you have all the work you needed in. The end. Please don't make me regret ending 5 minutes early. Don't bother gathering by the door or anything. You still have 5 minutes.
Dude, this is not supposed to be